If you get an agreement, stand up and then check with one of the groups that's standing. It's possible that you both made the same mistake, but not probable. Check with another group that's standing. If you get an agreement, stand up and wait until the whole class is ready. And once your group is standing, check with the group next to you. Uh-oh. Uh-oh. As some of you guys are still trying to get into agreement. People that are standing, go by groups to one of the groups that's sitting down and check in and see if they need any help. The groups that are standing, go with your entire group. Go be ambassadors and be like, hey guys, how you doing? Check their work, see how they're doing. Be creepy about it. Looking over their shoulder, not saying anything. Say, hey, how's it going? We're done. Go and check out those that are still seated. If they are good to go, or you've gotten them on the right track, feel free to go on back and grab a seat.
That's what it's yeah.
If you think they're good and they're on the right track, you can go on back and grab a seat. And be checking my answers to see if you agree. Someone who figured out they were, well, pause. Anybody match up with my answers? Sweet. Somebody who figured out, a group that figured out, you can all speak or one of you can speak, a group that figured out there were two cases. What reminded, lets you know, pointed you in the direction of two cases and not 0, not 1? Anybody? Tony? Okay. So one way is you could, and I kind of did this as an aside, like later on. I actually didn't know it from this, but this does show it. If you're looking at the example right now, A is less than B, which means it's not just 1. You should go looking for 2. If A is less than B, you should go looking for 2. Why is it not 0? For sure, for sure, for sure. Why is it a possible triangle? What did your calculator not do at any point? Never did error. So it is a possible triangle, at least 1. And how do I know 2? Not only is it less than 31, but Tony, what else is it? Yeah. So A is less than 31 and it's greater than the height. If A is greater than the height and less than 31, it's going to swing in and swing out, 2 cases. However, without even comparing the sides and the visual and what's going to happen with that little side, is it like, or does it go forward and backwards, or does it just go forwards, or straight down? Is it the altitude? What's the other mathematical way of doing it? When you go to find B, what do you have to do to both? Sine inverse, what should you check? Or 180 minus. And how do I know, just looking at these two, how did I know both of them are possible? I compare these two with 20.5. Can 64 something and 20 something leave room for another angle? Mm-hmm. Can 115 something and 20 something leave room for another angle? Mm-hmm. So even just the math, if you just get to, hey, sine inverse 180 minus sine inverse, that's why in the notes, what did I make you guys write that you should have written? When you do SSA, what should you check? 180 minus. Check 180 minus and compare to the other angle and say, hey, is there room for you? Remember yesterday, and the one that we were finishing up from the day before, yeah, there was room for a third angle in both. The next example that we did, nope, that was a visual, sorry. The next example that we did, sine inverse, and we checked 180 minus sine inverse. Why did this one cancel out? Because the original angle plus 158 was too big. 42 and 158 is more than 180. That's impossible. And then the next one that we did, when we went to go check, well, the calculator said error, so forget that. That was our 0 case. Hey, you. Thanks. Any individuals or groups still have questions? If you're good now, give me a thumbs up. There we go. There we go. Okay, let's go ahead and transition to homework. Color pen, let's go. Let's grade those evens. So we're going section 6.1. I'm going to leave up really quickly on the screen just in case you didn't get it down yesterday. I want your pencils, because you're not supposed to be using pencils. I want them in your notes, and if for any reason you didn't finish writing down these formulas yesterday, get them ready and then close the pencil in the notes. Colored pen and the homework ready to go. Because today we're going to be playing with law of cosines. Different formulas, but similar idea. Different formulas, but similar idea. Gavin, it might be helpful to see how many pages of notes, and then you can kind of skip that we took yesterday. We just did a couple more examples. That way you don't have to fall behind too badly. And the last thing I said yesterday, I think before you guys left, was something along hey, like law of sines, the formulas on the left and on the right are actually saying the exact same thing. The last thing I said yesterday were, just like law of sines, the formulas on the left and the right are saying the exact same thing, but law of cosines is a bit harder to see how they're the exact same thing, to see that they're actually saying the exact same relationships. So as you're just looking at the screen, either you're finishing writing them down or you're just pondering. I want you to ponder, how could you get from here to there? What algebraic steps would need to be taken? How would you get from the left to the right? What algebraic steps would need to be taken? Homework spirals open, colored pens ready. A couple more seconds for those of you still writing. And let's go. All right, section 6.1. Let's go ahead and grade. You guys can see number 10, number 30, number 44. As you guys are grading, Kyle, what's up, bud? We'll get back to that in just a sec. Hold on to it. Remember, when I grade your homework spirals on the day of the test, I am looking at you finished attempting, maybe by asking questions in class. You finished attempting. You graded with a colored pen, which should happen in class. That's the best way to save you time, but could also happen with a video some other time, I suppose. On the day of the test, you'll get 100% if you finished attempting, even after you turn in the Google Classroom assignment. If you finished attempting, you fully graded, and if you got something wrong, you figured out how to do it correctly. And I can tell that if you do it in colored pen. Hence why your pencil is chilling in your notebook right now. Gavin, what's up, bud? Number 30, when you went to go try to solve it. Right. It's an impossible triangle. Now, well, that's possible too. That's a struggle, right? Because it could be that you messed up in plugging in, but as long as your work matches up with law of sines, it is possible to get an impossible triangle. That sounds weird. And just showing you why, like visually, because that might be helpful for some. Uh-oh. Why are you being weird? H is the altitude, so let's pretend this was a right triangle is basically what H is saying. Let's pretend it's a right triangle. We would have to have 58. We would have to have 12.8. The guy who's in question is this guy. Like, what is he doing? So what you can do is you can solve for the altitude or solve for the height using the right triangle. And there, in all probability, this is not a right triangle. The 4.5 is either coming in or it's going out. But we're saying, okay, what is the height of this triangle? What's the highest? Lowest. What's the shortest distance between 2 points in some way is what we're finding. And we would end up doing what I did in class, which is, what, 12.8 times sine of 58, right? Because you would use sine, opposite, and hypotenuse. So sine of 58. The altitude, they call it h, is 12.8 times sine of 58. If you plug that puppy in, the shortest distance this side could be is 10.855. And why is that a problem? If that's the shortest the side could be, I have some serious issues. Yeah. So they told me make a triangle with this guy. And the problem with making a triangle with that guy is with a 58 and with a 12.8, there's no way to make it connect. Does that make sense? So that's the visual. It's just going to swing. There'd be one answer. It'd be a right triangle. And if we were to get something like 4 as our answer, then the 4.5 could have swung out and in. We would have had those 2 different options like the warm-up. Yeah. But the nice thing is the error in the calculator, as long as you plugged in correctly, tells you that without having to do this extra analysis of what's really going on. And the number 44 was a simple plug and chug to the area formula, right? You guys okay with finding the minutes? Remind me really quickly. Where are the minutes found? Second apps, the angle menu. Good. And you're in degree mode for all these, right? Cool. Did anybody use the other way of doing minutes without going to the menu? No? I kind of use it sometimes. I think it's faster. You could have done 5 plus 15 over 60. You could have used the conversion and built a little baby bridge, but that's okay. Second apps works just as well. Number 52, it would have been super nasty if they'd only given you 1 angle, but they did give you 2 angles, which was a little bit nicer. However, here's a question. Were they talking about bearings in number 52? Remember how we didn't really do tons of bearings? So the picture might have totally been where you got confused. So if the picture was totally where you got confused, I'm going to go ahead and just over here really quickly, if I can get this box to where I can move it. Even though I didn't force you to know it way back when, bearings will show up every now and then in chapter 6. So we'll try to get a feel for it wherever we are. Wherever you're standing, whatever point in space you're standing. Where's your north? Straight up. Where's your south? Straight down. Your east and your west from where you are. Assuming that the picture is oriented in north, south, east, west fashion. From whatever point you're standing. If you're standing here, there's your north. If you're standing here, there's your north. Wherever you're standing, your north would be straight up. Bearings say, instead of measuring from some weird, awkward east or positive x-axis position, it makes a lot more sense to measure from. So whenever we're talking about bearings, if they don't tell you something about southwest or northeast, if they don't tell you in what quadrant this angle is, you're going to be measuring from north some sort of angle. You're going to be measuring from north some sort of angle. And so if they mentioned a bearing of 65 at a certain point, or from B, if they told you a bearing, it would be from north. If they told you C, they told you a bearing, it would be from north. So that might have gotten a little bit confusing. We'll come back to questions in just a second. I think, isn't there another even that we need to check real fast? The problem is, I think the book doesn't really give us super nice pictures. I think it's really mad at me when it gets to, yep, see, it doesn't like these word problems. Yep, doesn't like the word problems. Ugh, so sad, doesn't show me pictures. I'm guessing you guys might have the word problems, but let's go ahead and check 56 and 62. 50. How do I full screen it? Can I do that? No. Can I do that? Nope. Can I do... Well, that doesn't really help you, does it? Show one page. Can I just do Control Plus? How do you zoom in, though? I was doing that, though. Control. Oh, nice. Oh, but that's as far as it'll zoom? That's lame. All right, well, I was trying, guys. It's just not working. Increase text size? Nope. All right, we'll forget that. think by now there'd be a better way than that. Okay, Leaning Tower of Pisa problem. Let me give you a second to go ahead and check out what's going on. There was a right triangle that was formed. And so even though the Tower of Pisa was over here, the right triangle with hypotenuse were both pieces of information that you were able to find. You didn't know what theta was, so you were having to use the variable theta and get an equation for number, or for part B, I should say, of number 56. And then you were going to your table and going every 10 and figuring out what was going on. But you were only able to make the table once you finished with letter C getting D by itself. So I'm moving down just a little bit. Letter B, the final formula is right here. Letter C, the final formula is right here. Number 62 was the other one that I was thinking about yesterday when I was telling you guys about a gray box. I guess it's a tan box, but either way, it was a similar idea of trying to figure out how to get one triangle, two triangles, no triangle. And you had to find the altitude or the height, pretending it was a right triangle, and then compare based on that. And that's how you end up with, if A is greater than or equal to 5 or equal to 3, that would be the right triangle, and this would be the swing in, swing out. Sorry, only swing out. So one solution for the right triangle for the swinging out. These are the ones in between the 5 and the 3 that could swing in or swing out. And if it's shorter than 3, it's shorter than the smallest possible distance, aka it's going to swing and never connect, aka the 0. Since 52, 56, and 62 I don't have pictures for, especially 52 and 56, we're actually not going to go over those questions today. I'm going to get pictures of them. I might even just post in your Google Classroom a couple description videos of 52 and 56. That might be the easier way than us using class time, because some of you might understand them and some of you might not. So let me go ahead and see the easiest way. Either I'll have pictures ready to go for us to discuss it in class all together tomorrow, or I'll make a couple quick little tutorial videos and post in Google Classroom about these ones, since the book sadly isn't giving me a picture, and it's a lot easier to go over these two with the picture. So let's ignore 52 and 56 right now. Are there any other questions that you guys have from odds or evens besides those two? Kyle? 17? I actually have that right here. Anything else besides 17? Except for 52 and 56? Oh my goodness. This is just hating me all over the place, isn't it? Well, I did have 17 a second ago. Half angle, that's last chapter. Here we go. Right away, guys. Why am I going to say watch out for case 2? What do I see in the given information? What makes my brain automatically say, uh-oh, watch out? Angle, side, side, right? Angle, side, side. Ah, stink. But wouldn't you, hopefully by now, naturally go ahead and put sign B on top? True? Are we doing okay with at least plugging into law of sines? Do we know we're going to have to do a sine inverse eventually? And when we do sine inverse, what do you need to do? So I'm going to check sine inverse. I'm also going to check 180 minus sine inverse. Have you guys gotten to where you can mentally rearrange it? What would it be sine inverse of? 5 sine 36 all over, because you multiply by 5 and then sine inverse. So it's going to be the same thing here. Now, if you wanted to know, like Gavin and I were talking a second ago, what case this is automatically, you could compare it to a picture and say, okay, if I had 5 and if I had 36, how does this guy compare? Is he too long? Is he just long enough? Is he somewhere in between, or is he too short? You could look and find the altitude, so I could go ahead and start calling it h like the book calls it, if that's less confusing. We'd end up with h is equal to 5 sine of 36. So you could know beforehand what should happen, just in case you aren't trusting your calculator or your calculations. And you would end up with 5 sine of 36 being, uh-oh, that's not what I wanted. Get away, tangent. 2.939. Guys, how does 8 compare to 2.939? It's bigger. So since it's bigger than the shortest distance, and it's bigger than 5, is this a possible triangle? Because with a really, really long side, can I deal with a really, really long side? Sure, just swing it out. And I'm going to have a really, really long third side. So when you go ahead and start solving for sine inverse and for 180 minus sine inverse, the sine inverse makes sense. So when you guys went and plugged in, you should be able to call it out. I'm just going to go ahead and throw it in so I can also. 21.553, true. When you got 21.553, question, can 21.553 room for a third angle? Yeah, which is why you got your angle B when it's 21.553. You got a possible angle C by subtracting from 180 both of the other angles, 36 and the 21.553, to be 122.447. But why am I going to put an x through this one automatically? How would I have found this guy? 180 minus the 21.5. You would have gotten 158. 158 point whatever plus 36 is bigger than 180. Is bigger than 180, and bigger than 180 is impossible in a triangle. So we would only do one case, which is exactly what this tells us. If 5 is greater than the height, I'm going to swing it out only. I can't swing it back since it's bigger than the 5 and bigger than the height. So then, Kyle, once you had the two angles, was the problem in getting the third side? Or are you okay now? Okay. Because then you just plug into law of sine, solve for C, and go. Got it. Okay, any other questions besides 52 and 56? Okay, help me out. Who has a question on 52? Oh, that's the extra credit. Who has a question on 56? Oh, okay. So maybe I won't take a lot of class time tomorrow on that one, but I might do the tutorial video. All right, cool kids, let's go ahead and get into law of cosines. Was anyone able to, when I asked you about that question, the left, well, I told you the statement, the left formulas equal the right formulas. Was anyone actually able to, in their mind, figure out how that's possible? Yes? So what if we were to take the very first formula? What if we were to take the very first, I should say, law of cosines formula all the way across, a squared equals? How does the left equal the right? I'm going to zoom in really quickly, if I can get there. What was your objective, those of you guys that were able to make it match? What did you do? You took this formula and solved for, yeah, if you look at this, cosine of A is in this formula. It's right here. And so algebraically, we would just have to get this by itself. And so when I go to my dual page in order to show how this works, and for some of you, this is silly, but for some of you, you're like, I wouldn't have to memorize 6 formulas. I wouldn't have to memorize those and those. I can memorize these 3 and have that one at the same time. Because if you started with a squared is equal to, hey, where does law of cosine start out? What formula is that? A squared equals b squared plus c squared. It's like Pythagorean. Now, Pythagorean is c squared equals a squared plus b squared, but if you have a different letter, then everything just changes, which is interesting. A little bit different than Pythagorean. We don't have a right triangle. It's a non-right triangle, but it starts off kind of like Pythagorean, and then you have this extra minus to the other two sides cosine of. One quick of making sure your law of cosines is right. It's bookended. What it starts with is the angle it ends with. Little a, you should end with capital A. If I'm trying to solve for what you guys just said, wouldn't the first algebraic step be subtracting b squared and subtracting? What you do to one? Minus c squared is equal to negative 2bc cosine of a. Now, how do I get even closer to him? Divide by negative 2bc. When I divide by negative 2bc, I end up... Wait a minute. Look at your notes. Is that the exact same thing? Yes, except what's not in the denominator? A negative. So what'd they do to it? Whatever was making noise, make it stop. What did they do to the negative? They took it out of the denominator and put it in the numerator. And so if you take that out, positive 2bc, it'd be a negative times a squared minus b squared minus c squared. And what happens when you distribute a negative? You get b squared plus c squared minus a squared. Now does it match? Yes. Now, would you have to do that? Not necessarily, but all the angles on the right really come from all the angles on the left. Now, really quickly, law of cosines, super, super nice for when you're given at least two sides. But when will you be using each of the different formulas? Well, technically, you could just memorize these three. But sometimes you're going to be missing sides, and sometimes you're going to be angles, just like law of sines. So let's go ahead and take an example and see which orientation you think would be easier. And you guys are going to have to figure out in this section, should I memorize both? Should I memorize both? Here we go. What if you were given a side, side, side? What if you were given a side, side, side? You're given a, little b, little c. If you look at your formulas, whether you plug into the left formula or to the right formula, if you plug in little a, little b, and little c, you'll only be missing an angle. Now, sadly, we can't solve for all three angles at once. If you look at your formulas, given little a, little b, little c, you can only solve for one angle at a time. So I need from you guys a direction. Which angle you want to solve for first? A? All right, cool. Then look at your notes and start with the formula that says cosine of A equals. If you want to solve for A first, look in your notes and start with the formula that says cosine of A equals. I'm going to come steal them so we can use them. If you want to find A first, we're going to use this guy, and we have to plug and chug. Some of you are already plugging and chugging. I can hear it in the little tippity-tap-tap of your calculator. Unless you're playing a game on the tippity-tap-tap. Hopefully not. Whoa, whoa, whoa. Why did I write A equals cosine inverse before I ever plugged anything in? Because who are we finding? Angle A. So I don't want cosine of A, I want angle A. How can I get A if there's a cosine of an A? Inverse. So B squared is 19 squared. C squared is 14 squared. A squared is 8 squared. All over 2 times 19. Now some of you might be like, aw, stink. Last section, when we had to solve for an angle, sine inverse, we had to do checking 180 minus sine inverse. Now here's the nice thing about cosine. Is cosine the same thing in first and second quadrant like sine is? Nope. Cosine is the same thing close in the first and fourth. First and fourth quadrants, cosine is positive. And the nice thing is, the fourth quadrant has negative angles, not obtuse angles, which means it's not possible to ever go in a triangle. Cosine inverse doesn't need us to watch out. Cosine inverse won't ever have a second case. Nice. So we only have to check with sine inverse, 180 minus. All right, you guys are hopefully doing second cosine. If I were you, I would use alpha y equals to make a nice pretty fraction. Alpha y equals and enter to make a nice pretty fraction. But then all you got to do is throw in your 19 squared, throw in your 14 squared, subtract your 8 squared, divide it by your 2 times 19 times 14. Is anybody getting 22.075? Ah. Now here's a dilemma. When it says solve the triangle, what does it mean? All the missing stuff. So we only have angle A. What do we still need? We only need to find one more. Kyle's right, because once we have two angles, can't we just subtract from 180? But now we have an option. If we have two sides and an angle, we could go law of sines, but some of you might remember, oh, wait, no, law of sines, one angle, I have to check two cases. It's probably easier just to keep on doing law of cosines. But for angle B, what's going to change? Now it's going to be B equal to cosine inverse. Let's see if you can get the hang of it. What changes? Yeah, for angle B, it's going to be minus b squared. So now 19 is here, and so the other two sides are here. 8 squared and 14 squared. Side B gets subtracted. At the bottom, it's going to be the other two, which is 8 and 14. So it's almost the same, but the orientation has to switch. Just a little bit. So then if I were you, I'd go up and steal your other expression and just change those little pieces. So instead of 19 and 14, it's 8 and 14. So 8 and 19 switch places, basically. 8 and 19 switch places, basically. Is anybody getting 116.80001? Hopefully at this point angle C is easy, because can't we just do 180 minus those two? Now if you're not able to use your calculator as quickly as we, come on in and let me test you on your calculator. Make sure you know how to use your calculator, because this is definitely a calculator chapter. Don't need to solve any sides, because all the sides were given to us. But yeah, once you're given two angles, don't reinvent the wheel. Just subtract from 180 and you've got it. It's a triangle. So what about this guy? What's different if you're given side angle side? If you're given side angle side, what's missing? For law of cosines, looking at the law of cosines formulas, what's missing? Jason, go ahead and go to Mr. Richard. Yeah, you can take your stuff with you because it's close to the end. For law of cosines, we need, well, the formulas involve three sides and one angle. We have two sides and one angle. So what are we missing? Has anybody figured out why is it that squared equals? It's the only formula that uses angle B. B squared equals A squared plus C squared minus 2AC times cosine. Why is this one nice? Isn't it ready just to plug in right now? But to find B, what do you need to do? Square root. Oh, plus or minus? Wait, Isn't B a side of a triangle?
Yes, it has to be.
Okay, so just positive. Oh, easy. Square root of the big old blah. But why did I use this one? Well, I had to. I needed B to be here. And if you look at all your formulas, the only way for B to be there is if I have B squared on the other side. But that's actually really ideal because I need to find that guy anyway. So square root of the big old mess. But what if I find little b? What's still missing?
The angles.
The angles. But can't you go to another formula? Maybe a cosine of A equals, and then once you have all your sides, you're good? Cool, kids. Play around with law of cosines. Let's see how we go. Let's go 75% for tomorrow. Sound good? P.S. If your camera takes pictures and it takes forever to load in Google Classroom, go looking for a PDF scanner app. If you can take pictures in a PDF, it'll load way faster. We'll talk more about it tomorrow, and we'll see how you guys are doing on your phones. If your phone takes forever to load, why don't you go looking for something like Tiny Scanner? Upload a PDF, attach a PDF instead of pictures. We'll talk more about it tomorrow in case it helps.
Does that look right? 1.6.
Yeah. Yeah. You got this.